This video is going to show you how to run and interpret a multiple regression model for the click ballpoint pens example. So remember the steps. We were first going to inspect our data and make sure there aren't any problems. We already did this during a previous video, but let's do it again. If you just plot the data, you're going to get one of these pairs plots, and this will be very useful for identifying outliers and other problems with the data. Okay, so there are no problems with this data. It's very clean. We now need to estimate the model, and so let's go do that. To estimate this model, we're going to do roughly the same thing. So sales is our dependent variable, and that's going to be a function of add, so there's nothing new here. However, we now want to include some additional predictors. So we don't want to regress sales and advertising alone. Let's add reps and wholesaler efficiency to this model, and then we need to give the data set, which is click. Now the next step is to we should do a summary, and in this summary we see the p-value at the bottom for that overall test of significance, so 2.2 times 10 to the minus 16th. So we want to test whether the overall model is significant. So the null hypothesis is that our three slopes are all equal to 0. In other words, advertising has no effect, reps have no effect, and wholesaler efficiency has no effect. And the alternative is at least one of these is going to be non-zero. The p-value is really close to 0. We reject h0 and conclude that there's something going on in this data set. So at least one of these predictors is related to sales. Now, having done that, we can start to interpret the regression coefficients. So let's start by stating the estimated regression equation. All that comes from this parameter estimates column right here. So the estimated equation is going to be 31.15 plus 12.97 adds, 41 reps, plus 11.5 wholesaler efficiency. I asked to interpret the coefficient for reps. So the interpretation of that coefficient is, for each additional rep, sales will increase by 41.25 on the average after controlling for advertising and wholesaler efficiency, or holding advertising and wholesaler efficiency constant. Then the increase in sales for an additional rep is 41.25 on the average. How would we get a 95% confidence interval for reps? Well, again, it's roughly 2 standard errors, and we could also get at that with the confint command. So here are your confidence intervals. Another question, is wholesaler efficiency different from 0? So if wholesaler efficiency has a slope of 0, what that means is it has no effect on sales. This is a really common test, testing these coefficients equal to 0, and we can just go to our output. So here in the output, we have the p-value, 0.143, and so that's the p-value. I show you how to work it out. This is what R does behind the scenes. This is how it ended up with 0.143. Notice this is greater than 5%, so we cannot reject the null hypothesis that beta 3 equals 0. It's entirely plausible that wholesalers have no effect on sales, at least for this company. Another type of problem that you may encounter is, let's make a forecast. Suppose I'm going to put 4 ads. I'll have 4 ads in some territory that has 3 reps, and this particular territory is a poor wholesaler. Then you'll see that the predicted sales is 218. Another question that comes up is which of these predictors is more important? So let's go back to the output. Which predictor is the most important one in the model in explaining sales? In part, we want to do this so that if we wanted to increase sales, which variable should we effect? Do we want to add more ads to the territory? Do we want to add reps? Or do we want to improve the wholesaler? So which one is more important? And the answer is not completely simple. A lot of people will say just use the estimated parameters, and in that case you'd conclude that one rep gets you 41 additional sales on the average, whereas an additional ad only gets you 13, and so therefore a lot of people would say reps are more efficient. The problem with that logic, though, is that what if a rep costs $100,000, whereas an ad costs you only $10,000? In that case, you could buy 10 ads for the price of one rep. So if you bought $100,000 worth of ads, then the sales would go up by 130 as opposed to 41 for reps. So the basic problem is that these coefficients aren't comparable because the units of the original variables are not comparable. So the best way to handle this is to find a common unit. My preferred common unit is dollars. So if I know what a rep costs and I know what an ad costs, then I can convert this to a common unit and make that judgment. There are a few other solutions to this. So another possible solution is to use standardized regression coefficients. The idea of a standardized regression coefficient is to standardize all the variables prior to the analysis. So you'll see that at the bottom I've standardized using the scale function, and I've re-estimated the model. We don't need the intercept if we lop off, if we mean center everything. So now what we've done in standardizing is to make the unit of measure the standard deviation of each variable. This has a number of problems, and I don't especially recommend this. I don't use this approach very often. So by making your unit of measure the standard deviation, you bring the design into it. So if you have a variable that has a large range, the standard deviation is going to be greater than if you have a variable with a small range. All right, so that's an issue. Here are some of the other issues with these. These are called standardized regression coefficients or beta coefficients. So what I just mentioned, if you're designing an experiment and if you select the x values, you determine the standard deviation and therefore the variable importance. Another problem is that if you have 0, 1 variables, the standard deviation is given by this expression. So the closer that the fraction of ones is to 0.5, the greater the standard deviation. The closer the fraction of ones is to 0 or to 1, the lower the standard deviation. So you're going to implicitly weight up values. So that's another problem. Beta values don't consider costs. We've already discussed that. And betas will still be a function of other variables in the model. So it's not so simple. Another approach is to compare t-scores. So I think the best approach is to convert to a common unit like dollars. The next best approach is to compare the t-scores. So let's go look at those t-scores. So these t values will be another indication of variable importance. And you'll see it looks like reps are a little bit more important than ads. So that's another approach to make